Hey Cody, I decided I would try a media response on this problem. So 84.83 divided by 17. Let's take a look at how that works. And I'll embed this or put the link in this response to you, and so you'll be able to see it. It took a little longer than I expected to get it ready. I had some more technical problems, but let's take a look. So 84.83 divided by 17, we're going to set that up 84.83 divided by 17. And so one thing I still think is a good idea is 17 is almost 20. 84 is basically 80. So we're going to just say how many times will 20 go into 80, right? And before we start, we do have a decimal point here, but we don't have to worry if the decimal point is in the dividend, the thing that's being divided. We just have to put it above the decimal point on this line. So we want to have everything lined up, and then we'll go ahead and divide. So how many times will 17 go into 8? That's 0, so I'm going to write that in. And then how many times will 17 go into 84? Well, we're going to call this 20 and this 80. How many times does 20 go into 80? Or how many times does 2 go into 8? So we'll go with 4 and see how we do. So this is basically just a guess, preliminary guess. But if you've learned my quick way to do multiplication by 5, like if you're thinking 5 might work, 5 times 17, you can do it in your head if you remember that you take half of 17, which is 8.5, and you move the decimal point over one place, which is like multiplying by 10, you get 85. So 5 would give us 85, which would be too big, so 4 should work. Let's try it and see. 4 times 7 is 28. Let's put the 8 down here and carry the 2. And then 4 times 1 is 4, plus 2 more is 6. So 68 is what we get. We'll subtract that from this number. And in order to do this, we have to borrow, because you can't subtract 8 from 4 normally, not without going negative, and we don't want to do that here. So borrowing 1 from the 8 leaves 7 and makes the 4 14. So 14 minus 8 gives us 6, and then 7 minus 6 is 1. So the main thing we're looking for with our answer here is that it has to always be less than this, the divisor. Because if it isn't, that means you didn't guess this number high enough, right? If this is higher than this, if your answer, the difference between the two numbers here, if that difference is greater than your divisor, that means your guess up here wasn't good enough. So you have to like back up a whole step and then increment this number by 1. But we lucked out. We came close, but it's fine. So now we're going to continue on to the next number. And down here, we can just ignore this decimal point. We'll bring down the 8. And how many times will 17 go into 168? And this is, again, guesswork. But let's call this 20, and let's call this 170. And how many times does 20 go into 170, right? 20 and 170. So you can kind of reduce these. How many times will 2 go into 17? All right, if we just take off the zeros, because the ratio will be the same. So 2 goes into 16 8 times, and we need a number that's less than 17, so that should work. Let's try that. And this may not work, but we'll go ahead and try. I'm going to get it already in a different color. So we're going to try 8 times. So 8 times 7 is 56, carry the 5. 8 times 1 is 8, plus 5 is 13. So now the difference here has to be less than 17, or we'll have to go back and do it again. So 8 minus 6 gives us 2. 6 minus 3 gives us 3, 32. Wow. So that estimation method wasn't very good, was it? 8 times 7, 56, carry the 5. 8 times 1, 8 plus 5. So I guess we're going to have to go to 9. So let's back up. This is the frustrating thing about division. Oops, I back up too far. All right, we're going to make it 9, our new improved guess. So this is like following scientific method. Our hypothesis was that 8 would work, and we did the test, and it didn't, so now we're back to the drawing board. So now we've got 9 times 7, that's 63, so put a 3 down here and carry the 6. 9 times 1 is 9, plus 6 is 15. This is looking a lot closer. 8 minus 3 is 5, 6 minus 5 is 1, and 1 minus 1 is 0. So we ended up with 15, which is smaller than 17, so we're good. And then we just need to bring down the last number, which is a 3. And they often give you a problem at WAMAP that doesn't have a remainder. So you know if you know your multiplication table well, you might guess what number times 7 gives 3. Can you envision that? And another clue here, and I've seen this pattern again and again at WAMAP, we just multiplied 17 by 9 and got 153. And lo and behold, right down here is that same number, so we ought to be able to put another 9 here. And now 9 times 7, 3, carry the 6. 9 times 1 is 9, plus 6 more is 15. And here's 0 remainder. So I think this last 9, maybe you didn't do this last step, but you want to continue this pattern until you have 0. Or more often, you're going to have a number that's smaller than this number. Your quotient, or your this is the quotient up here, your remainder. Your remainder has to be less than your divisor, and we'll do that soon, working with remainders. So do the problem until you reach 0 or you reach something smaller than this number. And there's 2 ways you can go after that. Either make it a fraction, or you can add trailing zeros out this side and divide it down for precision. You can put zeros out here and then get more and more precise answer. And generally what they do is go out that way until the numbers start repeating, or until you reach 0, or you reach the level of precision you want. Anyway, 4.99 is the answer, and that's what we're going to put in the box, 4.99. Give this a try, and I did get that module finished, so take a look at it and see how you do. Let me know if you have trouble. See you soon.